All right, we get to totally change gears, and that way we don't have such long problems. We're now going to solve things with radical expressions, and in order to get rid of the radical expression, we do the opposite of what's there. So in this case, with square roots, we do the opposite of taking the square root, which is squaring. We do have to isolate the radical before we try to get rid of it. So in this case, it's already by itself. We can just go ahead and square both sides. When you square that square root, it cancels out, gives me w minus 11. 5 squared is 25. And so when we solve that and we add the 11, w is going to equal 36. Now when you work with square roots and fourth roots, those with even exponents, you have to check your answers because sometimes you get what's called extraneous solutions. Normally they happen when you happen to square a negative. We squared a positive, so this one should be okay. If I take 36 minus 11, I get 25, and the square root of 25 is 5. Yep, it checks. So when we do number 11, the square root is not by itself. We have to get it by itself first. We're going to go ahead and add our 4 and say the square root of u minus 4 equals 9. Now that I have the square root by itself, I can square both sides. If I square both sides, what am I going to get? U minus 4 equals 81. So if I add my 4, u is going to equal 85. So 85 minus 4 is 81. The square root of 81 is 9, and 9 minus 4, sure enough, is 5. Yep, it checked out. So on number 12, first thing I'm going to do is subtract my 13. I would get the square root of u plus 7 equals negative 4. In this case, you may already recognize that if I have a square root, it's never going to be able to equal a negative number, right? You could stop there and say, oh, no solution. Square roots can't equal negative numbers, just like squares can't equal negative numbers. If you happen to go through and solve it, if you try to plug it back in and check it, it's not going to check either. But if you recognize that right away, hey, you get to be done.